waves. Who can define for me? What's a wave? Some might call it wave motion.
Transfer energy.
Transfer of energy.
Without medium.
Does it mean for all waves without medium? The medium or without a medium, we'll talk about that later. Through a region without transferring particles or matter. Sure, that's fine. So that's the definition of a wave. All right. Now, you mentioned about medium or without medium. Okay. So, can you tell me what particular type of wave transfers or travels without medium?
Yeah.
EM waves. Okay. EM waves do not require medium. So you notice I put the word waves in the middle. I can branch out to many things. I want to. Okay, you can do this. This is called mind map. Some people call it a cheat sheet. The beauty of this is you can write it in whatever way you want it to. Do it at home, connect everything together. Okay? I mean, you don't even need to put this here. You could just link it directly here. Because we talk about requiring a medium here. So really, it's really up to you to connect the dots in however way you want. You can use different colors as well. Okay, so tell me, what waves do require medium? Sound waves require a medium. Any other waves that require a medium? Ocean waves, water waves, yes. Other examples? Water waves. Right? I love because it reminded me of the ocean. Why is the ocean friendly? Because it waves. Yeah, that helps you to remember. Oh, no one laughed at my joke. How proud? How proud? Continue doing your attitude. Okay, now let's use another color. What type of wave are EM waves? General type, category. Transverse, yes. So who can define for me what is a transverse wave?
Go perpendicular to the wave line.
Okay, answer in terms of your highest chance to score that 1 mark. That 1 mark is a 1 mark question. So if you were to write down the answer,
particular up and down the line. The wave line.
you want to try, Christine?
Particles move perpendicularly to the direction of wave travel.
When you talk about particles, what particle are you referring to? The particles belong to who?
Wave.
Yeah. The wave particles vibrate / oscillates in a direction. Oh man, running out of space. Perpendicular to the direction of the wave motion. Or wave propagation. Okay, so that is the definition of a transverse wave. What about a longitudinal wave? Any examples that we are looking here, which is a longitudinal wave?
No.
Yeah. So this one is a long wave. Then you could just branch it out to somewhere where there's space. Obviously, I lack of space. So we don't have to go through everything. But what is the difference? So you could put here similar to transverse, except what?
Parallel to
Yeah,
wave
except
direction.
parallel to wave motion. Okay? Okay. What's next? What do we know about waves? Any other thing?
Compression.
Okay, compression, since you mentioned that. Compression and rarefaction, what are they related to?
And wave. Sound wave.
Sound waves. So what is compression and what is rarefaction?
Like the particles move to Bishan.
So the region in which the particles are compressed with each other. Okay. So you can also draw. So this is one of the wonders of making your own cheat sheet. You can also draw. Okay. You can say region in which particles are closest together. Then this one is particles furthest apart. Right? So can anyone tell me? So you gotta choose the one in the middle, yeah? Can anyone tell me what does this represent? Half a wavelength. Okay? So it's under sound. Notice my arrows. I branch out based on the last relationship I have from that topic. This is how you connect blocks. This is the meaning of a mindmap. Okay? So over here, let's talk about wavelength then. What is wavelength?
One complete wave.
Again, an answer in which you expect to score full marks for the question if it comes out in exam.
Between two successive.
Okay, it could be two successive crests. But in general, two successive points of the same base. Okay, now the points could be crest. Oh, bless you, man. Bless you. Points could be crest or troughs. Right? What do you mean by same phase?
Same. I think position by different, but
So let's draw it out. Now, crest to crest we know lah. Okay, so C to C we know. Troughs to troughs we know. Okay, but you can also use this as well. This is called same phase. These two are the same phase. And they are next to each other, they are consecutive. So the next point of the same phase, you take that point and you find the distance between the 2 points. That's also a wavelength. So this is also a wavelength, by the way. Again, you can draw this out because it's your mind map. You can do whatever you want with. Okay, so these are things that you guys need to study on your own and write this out. Right? So that's a wavelength. How is wavelength related to wavefront then? Let's draw.
It's on the wavelength.
It's on the wavelength.
The wavelength on the wavelength.
So these are straight wavefronts. So can you tell me how many wavelengths are there in the picture? Justin, what do you think? There are 4 wavelengths or 5 wavelengths? How do we know? Correct. Answer is 4. So this is 1, 2, 3, and 4. Okay. So again, you can draw a link to over there, connecting the points. All right. What are wavefronts? What are wavefronts then? Again, a 1-mark question. This is fun.
Imaginary line.
Oh, wow, somebody's doing his work. Imaginary line.
That the wave is rectangle. I cut through the wave.
You're very funny, you know, because you started on strong and you're like, I got this imaginary lines, okay? But the rest is like, you gotta finish, okay? When you're revising, you gotta go through all the way. You gotta memorize the whole thing. Memorizing the beginning only gets you so far. Imaginary line connecting points of adjacent waves that are of the same phase. Okay, again, you can draw this out. You can even draw it here if you want to. It will look something like that. If let's usually for wavefronts, we connect the crest. So if you draw a wave here, draw the wave such that it cuts through the crest. And you can do that. So this will be the adjacent wave. This is how the adjacent wave will look like. So you notice I'm cutting through all the crest. Crest to crest. So this is what it means by adjacent wave. Adjacent means they're next to each other. Okay? All of these are possible warm-up questions that can come out on Thursday, which is your WA1. Any questions? Ken? There's more. but I don't have space. Okay, which means that I have to erase. Okay, so assuming that you have enough space and you are continuing the mind map. So on wavelength, we have completed. Let's talk about frequency. What's the definition?
Number of wavelengths per second.
Number of waves generated in 1 second. Okay. Some might say number of oscillations. That's fine. Number of waves or oscillations generated in 1 second. That's the meaning of frequency. What about period? So from here you can branch out the period. What's period? Time taken to what? Complete one oscillation or one wave. Okay. Now what is the, so if you combine these two, you can draw two arrows here. What's the mathematical formula for it? T equals to what? 1 over F. What is the SI unit for frequency? Hertz. Okay. What's the SI unit for period?
Okay.
So if you encounter something that is in milliseconds, you will then have to convert. Or minutes, then you have to convert. Okay. So you combine all of this. You have wavelength, you have frequency, you combine all of this. What is the wave formula or the wave equation? What is the wave equation? V equals to F lambda. You can box this up. This is known as a wave equation. And this is meter per second. Hertz. Meters. All right. We talked about wavefront just now. Okay, so you have shallow and deep. So let's say you travel from a shallow to deep region. What can change? Okay, so we have V, F, lambda, and now we have E, F, lambda here. Okay, so all I need for you is to tell me which one remains the same. No, the speed doesn't remain the same. Oh man, F is a constant. Why? Why? Depends on the source. Good. What about the lambda? What about the speed? Let's talk about speed first. Speed. Okay, so it goes to the deeper region. Speed increases. And because of the formula, okay, lambda, therefore will increase or decrease? Okay. Lambda will increase. Why? Because if you increase your speed and your F is a constant, your lambda should increase. Okay, then you're expected to also draw your wavefronts. So you could just draw it here. If your lambda is bigger now, so let's draw lambda wider, and then draw smaller lambdas here. It should pass through. And this will be the boundary. It's having a good time. Okay? Wouldn't you like to be those kids in the playground, huh? Just throwing stuff at each other. Any questions? Yeah, so all these are essentials, things you need to know before your test. If you found that you've forgotten about it, you've got to revise.
But I mean, because you see got the smaller, the more of the real thing inside the students. And then you like got more people, they got higher frequency.
No, that's a good question to ask. So basically, think of this lines here represents the wave front. Okay, these are wave fronts. All right. So think of it as if you draw the cross-sectional portion here, right? The wavefront themselves, they are more or less squeezed in between the water level. So this is the water level. They're more squeezed in between here. Whereas here you get the wave fronts are being stretched out. Now the source is here. Let's say you got a source producing it. Okay, so the fact that they are closer together, it doesn't mean that the frequency has increased. It means that they there's a lot of tension, there's a lot of frictional force happening here, slowing the wave down. As a result, they are being squashed together. Whereas over here, they are spread further apart. All of them are produced in the same amount of time by the source. Okay, one way you can think of it, if you translate each wavefront to a human being. So basically, the number of imagine this is a room where you can enter. So the first room is smaller space. So the number of people are being squeezed together. Whereas the second, when you enter the next room, there's more space. So these people are being they have more space to move, so they are spread further apart. But in both situations, the number of people entering, which is the frequency, the number of people entering are the same. Number of people entering. It remains the same at all times. But because the first room is tighter, lesser space, so the people are forced to squeeze around from each other. Whereas the second room has more space, so they can be spread further apart. So it doesn't mean that the frequency is changes for both of them. It's just that whether you got more space or lesser space to be. Okay. So this part is important. The F is a constant. All right. Any other questions? Yeah. Essentials, which means that the rest depends on the part of questions you are dealing with. Oh wait, there's more. There's actually more. A few more stuff. Other basics like amplitude. What's the definition? Maximum. No, amplitude is the maximum displacement. Okay, so in terms of a graph, xt graph. So simple test. So if A is negative A. So what is the amplitude of this graph? Is it negative A to A? What's the amplitude of the graph? I've got A. Okay, a lot of people think it's 2A. It's actually just A. Amplitude is defined as the maximum displacement of a particle. So this is what you should be looking at only. Okay, you can't go all the way down. Right? So whereas this, if you take the magnitude, you still get the same value. All right. But you shouldn't add the two values together. There's only just one value. So amplitude is a maximum displacement. And amplitude is related to a property of a wave. What property is that? No, even the longitudinal wave also has amplitude. It's related to energy. What this means is that if you have higher energy, if you have higher amplitude, that means you have higher energy. Okay? In terms of sound, there's also a relationship. Do you know? Higher energy or higher amplitude in sound means what? Greater loudness. A higher amplitude means greater loudness. You talk about pitch. What is pitch related to? Pitch is related to frequency. So higher frequency, higher pitch. Frequency is related to what part of the graph then? XT graph again. Okay, so let's say I draw this. Okay, and then suddenly it becomes like that. I should draw the same. Suddenly you have this. As the frequency increase or decrease over time?
Phase decrease.
Frequency decrease, okay, because the period has increased. Frequency is the inverse of the period. Okay, this could be a question that comes up. Right? Wow, I'm giving you so many possible questions. Okay. Can what is next? Yeah, that's all for waves and sound for now. EM wave. Let's talk about EM wave. What are the properties?
Only medium.
Okay, we talk about that just now.
Speed of light.
Now, the speed of light doesn't just necessarily belong to light itself. So, what's the speed? The speed of light is the speed of EM wave, which is a number.
3 and 10.
3 times 10 power. We always talk about the speed of light, but the speed of light doesn't belong to light. It belongs to the EM wave. So they all travel at the same speed. Any other properties that you can think of? They follow the wave equation. This wave equation is a bit unique. It starts with C equals to F lambda. So usually you will have V equals to F lambda, but this is C equals to F lambda because the C is this. Okay. The rest are lesser known properties, like for example, we follow the law of refraction and refraction. Okay. So what are the families? Eunoia.
Yeah.
That's fast. What are the family of?
with
Okay, so we have. I think I need more space. I'm just going to. What's after radio wave?
going
Okay.
if I like ultraviolet.
Some might call it UV, ultraviolet rays. Okay, which one has the highest frequency?
Gamma ray.
And therefore the lowest F is here. Which one has the highest wavelength? Greatest wavelength. So greatest number. What is the estimation of radio waves wavelength?
Okay.
Size of a building. Gamma ray?
Okay.
Size of, wow, you remember all these, huh? Okay. Then this would be butterfly. Remember all this, right? Head of the pin. This one is atomic as a size of the atom. Okay. How about visible light? What are the different colors of visible light?
The people whether do
Roy gave birth in Vietnam. Okay. Do you notice there's a V here and there's a V here? So this is ultraviolet. This is violet. Ultraviolet is after violet. What about the R here? Infrared. Infrared and red. Infrared is before red. Okay. So the word ultra means you're higher. The word infra means you're lower. All of this refers to the frequency. Ultraviolet means violet that is higher in frequency than the visible violet. Infrared means red that is lower in frequency than the visible red. Okay? Extra information, the wavelength for here is between 400 to 700 nanometers. Are you required to remember that? No. But if you are studying A-level physics, will be required to remember it. It'll be very helpful. Okay? So this is for EM wave. Okay, a quick one. What about applications? Let's talk about application. Okay, radio wave used for what?
transfer of with
Transfer of what? COVID data.
no the yes.
No, GPS is not. Confirm not. Radio wave can never be used for GPS. Radio wave is only for local broadcasts within the region. Why radio wave cannot be used for GPS? Yeah, cannot be used for GPS because it cannot pass through. Yes. All right. So what is being used for GPS? Microwave. Okay, GPS, satellite communications. What else?
Microwave oven.
Food lah. Okay, heating up food. Microwave oven. All right. Okay, infrared. What is it used for?
Heat sensor.
But what kind of applications do we need heat sensors for?
At night need to find the forest fire.
Forest fire. Oh, I remember what I said. Yeah? Forest fires. What else? At night, what? Burglar alarm. Okay. TV, remote. Okay. Further on, visible light. What's it used for?
The light wire.
Again,
The fiber.
fiber optics. Okay. Speeding up. UV. What's it used for?
Clean the thing.
Again, you got to use the right word. Sterilizing of medical equipment. And any other things? Forensics. Detecting what? Wow, I got no space already. Start at C. Counterfeit notes. Okay? Use different colors. X-ray used for what? Broken bones. Medical diagnosis. Okay? For bones, fractures, and all that. What other things are X-ray used for? Cracks in metal pipes. Cracks in metals. Gamma rays. Not chemo, radiotherapy. Chemo is you inject in the patient. Radiotherapy is radiation. Okay?
Bomb.
Surgical knife, sure, nuclear bomb. But nuclear bomb is under nuclear physics. X-ray, gamma rays is not used to make nuclear bombs. Gamma ray is produced when a nuclear bomb detonates. Anyone got watch Oppenheimer? No? And you guys should watch that show. That was the coming to the end of the COVID era, and two very popular movies came out during the time. One of them is Oppenheimer. What's the other one? You remember? Barbie, yeah. Yeah, that was interesting times. Okay, that's about essentials, essentials for EM wave. Any questions? Okay, we're done. We are done.